This is Torrin, Anna, and Kyle, and we're going to cover some solutions for the urban heat island effect. So most of you probably know what the urban heat island is already, so we're just going to give a brief description. It's basically just an urban area or metropolitan area with higher inner city temperatures than its, when compared to its rural or less developed surrounding areas. Some implications: the higher or the inner city temperatures can be 2 degrees to 5.5 degrees warmer inside of the city as compared to its surroundings, and this could lead to higher energy costs through the use of air conditioning units, and this can lead to higher emissions, which then lead to individual health implications like asthma or just general discomfort and even heat-related deaths. The EPA states that cooling demand can increase up to 2% for every degree Fahrenheit in increase in air temperature. Right here is a thermal image of Phoenix, right? That little orange, I can't really point to it, but the really bright little orange spot is Sky Harbor Airport, I believe. And this is just to show you that it's also, the urban heat island is also very prominent, even more prominent during the nighttime, with it's about a 20 degree Fahrenheit difference between the urban center and the desert landscape, surrounding landscape. This second point will lead us into our first solution. If you increase the reflectivity in a city area by 10 to 30%, you can decrease the air temperature by up to a degree Fahrenheit. These are some research methods that we use to gather our data, which is included looking over case studies and implementation of our solutions, as well as local programs here. So our first solution, and before I go on, let me just mention that we collaborated with the other groups, the other UHI groups, in an effort to prevent us going over the same solutions over and over again. So you guys are going to see different things within every presentation. So again, our first solution, cool pavement. A brief description: it's basically a coating that you put on, usually asphalt, to increase its reflectivity properties, which in turn doesn't allow as much heat to be absorbed by the material, which equals less heat being released during the nighttime, less urban heat island. So some benefits of cool pavement: it prolongs the surface life of asphalt because it doesn't absorb as much heat, and heat in itself is a deteriorative force for asphalt. So take some of that away and you have a longer life. It can make asphalt up to 100 degrees cooler. That's kind of optimal. And then it can also reduce the need for lighting by up to 30%, once again using that reflective property to increase the range which light reaches. And emissions: it can offset 1 or 10 tons of CO2 per 1,000 square feet of cool coating put on black asphalt. And it's also LEED Green certified for its beautification, customer appeal, and public safety aspects. And you can save 0.05 kilowatt hours per square foot of cool coating.
So I'll be talking about implementation. The company that we have kind of looked at is Emerald City's Cool Pavement, and they've done a couple of projects around the city of Phoenix, like greater Phoenix metropolitan area. And one of the initiatives that they have is the 100 Cities Cool Pavement Initiative, which they kind of look at the 100 biggest cities in the nation and decide, let's kind of set up a program to help them install this. So that includes like reducing labor costs, and it gives them media coverage and the tools to monitor the progress of the project and see how effective it is. So we highlighted this just to kind of say that there is opportunities for sponsorship, and we're kind of looking at installing this at schools and like parking areas where it's less wear on the actual surface. And one of the cool things about the cool slurry that they use at coat parking lots is that you can use it to repair and maintain asphalt surfaces. So that's a big problem here in Phoenix, especially. We always complain about having to go through road repairs and bad, parking lots. So you can use the cool slurry to actually repair and maintain the surfaces of asphalt. And like Brandon said, it prolongs the surface life of asphalt. The cost, it starts at about $806 per 1,000 square feet, and it ranges from $800 to about $1,800 depending on how many layers you get and other coatings you get on there. And so that's one of the kind of trade-offs of the cool slurry, cool pavement, is that it's kind of expensive, but we kind of view it as a long-term investment because it will save you money on, power and emissions. So this is the Duffy Charter School in Phoenix, Arizona. It's kind of in the heart of Phoenix, so there's a lot of problems with UHI associated with the school. And Robert L. Duffy opened the school in September of 2010, and he decided, I want to make this the first zero-carbon campus in Phoenix. So he started off from the get-go with a zero-carbon initiative, and he's like, why not take it a step further by installing the cool pavement? And by installing that, he avoided 22.5 tons of CO2 emissions just by saving energy inside the school. So yeah. And then this is white concrete. It's another one of the strategies we viewed to increase service albedo inside the city. So we're kind of highlighting it as an alternative for sidewalk use. And so the traditional concrete has a solar reflectance of 40%, so 40% of the light that hits traditional concrete is reflected back into the atmosphere. But with white concrete, it's 70%, so that's almost double. But again, the trade-off of this is more expensive, so it can be up to double the price of traditional concrete, but that's, long-term investment again.
All right, so this is rubberized asphalt concrete and a rack, and it's classified as a porous material. So it's less dense, and the sources that we use to gather info on this, where it's implemented in California and even here in Arizona, they both mention that it can help with mitigating the UHI. Because of its lower density, it releases heat quicker. So similar to xeriscape landscape that we'll be touching on later. With its ability to release heat quicker, it doesn't carry on throughout the entire night like regular asphalt or concrete would, which continuously releases heat for a longer period of time, increasing the urban heat. So some economic benefits for this is that it lasts up to 50% longer, so you save a lot of money on maintenance costs and construction traffic. Environmental benefits, I think in Maricopa County we use and throw away about 2 million tires every year. So, and that can pose a fire threat as well as just a waste of space using to throw away tires. So for every lane mile that's paved, we can use up to 2,000 tires, so it's a very good use for that. And you also use less energy, which equals less emissions to produce this material. Social benefits, it can reduce noise pollution by by around 5 decibels on average. And to give you an idea of what this means, it's kind of similar to cutting the speed of traffic in half. So if you're going 60 miles per hour, it'd be like hearing a car going 30 miles per hour.
Our second solution recommendation is the adoption and implementation of an urban forest, which is essentially the planting of trees and other vegetation in commercial and residential areas. And they provide a series of economic, environmental, and social benefits. Economically, urban forestry will save money through energy costs, and they do this by shading and transpiration. And for those of you who don't know, transpiration is the process of trees taking liquid water and evaporating them through water vapor, cooling the surrounding environment. Additionally, it has been documented that the cooling benefits range between 1 to 9 degrees Fahrenheit, depending on the type of tree. And additionally, strategically planting the trees can reduce energy costs by 25% in residential areas annually. Urban forestry can also save the city money with a documented return of investment in Arizona for every $2.23 is returned for every $1 invested. And just to add on, additionally, it increases property values by 10 to 12% in residential areas. Some environmental benefits include better air quality and stormwater runoff, and socially increased connectivity through walkable communities and recreational areas. Next slide. Okay, so for the City of Goodyear to receive this high return of investment and all of the benefits that we just stated, we have several policy recommendations for you guys to adopt. To begin with, we recommend developing a tree planting campaign which would cover the city by at least 25% of the urban area. Another aspect of this would be to create partnerships with organizations and volunteer groups, as well as develop a community outreach program to increase awareness and educate the people about why there is a benefit for planting these trees. Another aspect of this campaign would be to develop policies and standards. And for example, we have a parking lot ordinance that would create one tree for every 4 spaces. And we also have irrigation ordinances and landscaping guidelines, which we will touch on in xeriscaping. Costs, as you can see, are purchasing, planting, and maintenance. And to pay for this, in case it is not in your budget, there's a community challenge grant that funds urban forestry initiatives in Arizona. Just to give you a better idea about other case studies, Phoenix has documented a UHI annually for over $1 million in savings, and they were able to do this with the Davie Resource Group, which would provide a free estimate to maintain and plant the trees.
All right, so I kind of wanted to touch on, go in more detail on the urban forestry program. We are looking for xeriscaping, which is a process of planting trees and plants with low water demand. Specifically, we were looking for light-colored rocks and coupled with xeric trees that can provide shade to reduce the UHI effects. And one of the case studies that we found was in West Phoenix before and after they implemented xeriscaping, and they found with their 50% coverage that they implemented, they reduced temperatures by 4.68 degrees Fahrenheit during the peak hours of 4 p.m. and 0.9 degrees Fahrenheit at night. Okay, and some of the programs that we found in the area to help implement these xeriscaping techniques is the SRP Shade Tree Program, which provides residents with up to 2 free xero trees. And some examples of these trees are in the middle, in the yellow is the Palo Verde. And on the far right, there's the desert willow, and those are just 2 of the 6 trees that residents can choose from. We recommend that a tax rebate be used to really implement or really push residents to adopt xeriscaping in their yards. And in conclusion, cool pavement is a major investment but can produce significant results long term. In urban forestry, specifically using xeric trees tailored to the desert, is viable due to the low water usage and the ease of implementation. They're both long-term investments, and it benefits social, economic, and environmental aspects in the city. Some of the challenges we face come in the form of trade-offs. The cost of cool pavement in exchange for the cooling effects are really, you kind of have to weigh those, and the variability of Goodyear kind of poses a problem for us because it complicates calculating how much cool pavement and xeriscaping can be implemented. Cost and energy benefits can differ based on the region they're implemented in, so you really have to weigh those.
Questions?
Let's thank our team first. First questions from the class, Casey, go ahead.
About the SRP Shade Tree Program, now they pay for the tree, they pay for the installation, how does that work?
They give you the tree for free.
They give you the tree for
Yeah, and they have their own free workshops that show you how to plant the tree.
Okay, but it's still incumbent upon the residents to plant them where they need to be planted.
Yeah,
Yeah,
but they give you saplings, so it's not like it's a whole tree that you're putting in your truck.
Yeah, it's not a mature tree, yeah. So it's,
yeah, you get like a 4-foot tree.
so it's going to take some time for it to reach its full benefits, but
Yeah.
Okay.
The Valley Permaculture Alliance has like a day where they help involve with that.
Anything from the city?
I had a question. When you gave the comparison in temperatures caused by the xeriscaping in West Phoenix, what was the condition before the xeriscape was there?
I believe it, I mean, they had little to no xeriscaping done, and after they put their treating program in, it was 50% coverage. So the difference was that, I don't know the exact hours that they had before, but
So did they have bare ground or did they have,
yeah, like
grass?
relatively, yeah, it was bare ground, it was gravel, yeah.
Okay.
Any other questions or comments? Go
I
ahead.
have a question. You mentioned under urban forestry that you had a $2.23 return versus the $1 investment with trees. Where did you find that particular fact, and I guess how would that relate to Goodyear specifically?
Yeah, so this fact was pulled from Phoenix's Master Shaded Tree Program that they have implemented already for their goal for the year 2030. And this was in Arizona, so they did a study with the U.S. Agriculture and Forestry Service, I believe. And so with Goodyear, the Davie Resource Group would help you track all of the trees that you plant with GIS services, and so they'd be able to pull out the economic benefits from that.
Let's thank our friends. Go ahead, Lily. One last question.
One last question. You talked about the cool pavements in the beginning, and I was wondering what was the scope in terms of the scale that would be required to make a difference for the city of Goodyear, because we didn't have the map of the city, so it's very difficult to kind of visualize that. Do you have a sense of how much in terms of distances and miles of cool pavements you're talking about in order to make a difference in the urban environment?
That really depends, depending on whether you put it, so for example, if you were to put it in front of like, or on the road and stuff like that, okay, just compared to, I guess I'm trying to go off of energy costs here, not really the UHI in total.
So what I'm
So
trying to
yeah,
say,
we don't have a
is it
number on the
residential buildings or commercial buildings, or is it on the highways? What are we talking about in terms?
So this could be placed on parking lots or highways or roads. It can be placed anywhere where black asphalt is currently in, so it can basically be
But
used.
the city would have limited resources, so where would you recommend them putting that would make the greatest difference?
We didn't look specifically into specific locations within the city to be implemented, but it's, I mean, that require, I guess, more.
We thought like
Research
parking
into-
lots and probably like schools.
Parking lots would be the easiest, yeah.
It's where it's,
It would require,
the most
yeah.
surface area that's on.
Because if you decide to install it, it takes like 4 hours before you can actually use it. So it's real quick to use, but we were just thinking it's kind of inconvenient to close down streets and paint them
Yeah.
and say, you can't use this for 4 hours. So we were thinking like parking lots and school services.
How many years does it last? Once you do the coding?
How many years?
I think
We
it's
have-
like 10, I think it's like 10 to 20. Depends on like how much traffic goes.
It also depends on the layering you use, because there's different, you can do like triple layer with like different materials on it, in it, so it also depends.
Can you combine the rubberized and
Oh, yeah.
Oh, cool.
All right, let's cut the questions here. So,